Welcome to our first live stream of All Things Automotive. If you're curious about what AWS is doing in the automotive industry, you've come to the right place.
This is a show where we dive deep in the auto tech news of the week, look at emerging technologies, and talk with our AWS customers and our own specialists on some of the most important issues in the automotive industry.
We have an exciting season planned with at least 8 shows, all themed around edge to cloud, with a focus today on vehicle software architecture and our partnership with BlackBerry and their IVY platform.
I can't wait to get into the details, Dean. I love that we are making it easier for developers to write embedded software for the industry. So, are you ready to start your engines, Dean?
Absolutely, Stefano. Let's roll. Welcome, everyone. I'm Dean Phillips, Worldwide Tech Lead for Automotive at AWS.
Hi, I'm Stefano. I'm Principal Specialist Solutions Architect in AWS.
I'm based in the Motor City, Detroit, Michigan. How perfect is that for all things automotive? I've always had a passion for things with engines, not just cars and trucks, but planes, boats, motorcycles, you name it. Combine that with my love for technology, I can't think of a better industry to be in at this time, or a better co-host to do the show with. Take it away, Stefano.
Thank you very much, Dean. I'm originally from the Italian Motor Valley, around the Bologna area, And I started loving computers on my side, and that's why I'm here in the Silicon Valley right now. But almost immediately, I thought that applied computers in cars was even cooler. So, right now, I'm really focusing in using computers on autonomous vehicles.
We're really excited for what we have planned for the show this season. We've organized all 8 episodes around the theme of edge to cloud and back. And here's a member of our All Things Automotive team to tell you what's ahead.
It's an exciting time in the automotive sector. Connected, autonomous, shared, and electric vehicle trends are converging to evolve the automotive industry of today into the mobility industry of tomorrow. Dean and Stefano would like you to think of them as your informed, passionate tour guides. They'll help explain how the world's leading automotive and mobility companies are driving change and innovation. In our first season, we're going to take you on an 8-week journey through some of the key areas in the sector, taking you from the edge to the cloud and back. Along the way, we'll bring on some customer guest experts that will offer technical insights on critical areas of the industry, like 5G, data pipelines and APIs, connected experiences, enterprise data lakes, cybersecurity, and more. We'll be sharing tips for builders in the automotive space, covering categories like AI, ML, IoT, and analytics, and give you our opinion on the latest news in the industry, and sharing resources so you can know all things automotive. It promises to be a great ride. This week, we'll start our live stream journey with BlackBerry and talk about the intelligent vehicle platform. Stick around.
Whoa, so much happening in the auto sector right now. And so, after that, I'm ready to go on a road trip. What about you, Dean?
Absolutely. My bags are packed and ready to go. But before we bring on our guests, we'll kick things off each week with a little discussion about some current events in our industry. So let's get going, Stefano. What's driving in the news these days?
What did I read about Ford selling more EVs than Tesla last month?
Yeah, Ford sold over 3,700 EVs last month. And Automotive News, they reported that Tesla's EV market share dropped 12% year over year in February. And that was almost exclusively to Ford's success with their Mach-E. Now, I'll leave the detailed numbers to the analysts, but one thing is certain, the market has clearly shifted.
Yes, there is no doubt about that, Dean. Bloomberg reported that the recent teardown of the Volkswagen ID.3 found the platform fully cost competitive with Tesla and boasted best-in-class energy density and efficiency. UBS Group analysts called the car, and I quote, the most credible EV effort by any legacy auto company so far.
Well, electrification is real. There are signs all over the place, but this one really blew me away. Guess who is assembling cars for Fisker? Foxconn.
Yeah, can you believe that? if you think about it, there are many affinities to mass producing iPhones and electric cars, right? At least in the sense of electronics and batteries. So the confluence of electrification, autonomous technologies are really reshaping how startups are breaking into the automotive industry, for sure.
Well, not only is Foxconn moving into automotive manufacturing, but with the formation of MIH, they've created an alliance of companies that are collaborating openly on the entire aspect of EV design, including ADAS and autonomy.
Yeah, their skateboard architecture is very cool. But what is most interesting to me and other developers is the vehicle software architecture. So that is where I see tremendous opportunity and really what has become the foundation of our live stream, the series this spring, right?
Exactly. It's all about in-vehicle edge architecture and how it gets rendered to simplify the development lifecycle and specifically to achieve environmental parity in the cloud.
Oh,
What the heck do we actually mean by environmental parity, Stefano?
yeah, it's a kind of a nerdy term, but it's a
Yeah,
central
like
concept
us.
in this revolution. Yeah, because it enables another geeky concept, right? Software-defined vehicles. Think about how software is developed in computers, in the cloud, and before environmental parity, many steps were needed to deploy and execute the same software in cars to assure consistent behavior, right? With environmental parity, this consistent behavior is achieved by construction. So you can be sure that what is developed executes the same way in the car because the local execution environment is the same no matter where local is, the cloud, the developer computer, or the car. It's like when you develop for an iPhone, right? You don't develop on the iPhone, but you are sure that developing on your Mac is a good proxy for what you will see executed on the iPhone.
I mean, it would be fascinating to imagine the possibilities developing software in cars with the same speed and flexibility that we do in the cloud, just like developing an app designed for your phone. But in order to do that, we need to move from these many specialized, ECUs with their own firmware and specialized hardware, and get to more larger generalized computing architectures that support a number of different functions and capabilities, like containers and even virtualization.
Yes, and again, it's a trend that is hugely accelerated by the electric vehicle rush. The future is not an iPhone on wheels. It's more like a data center on wheels. Data
Absolutely.
center and automotive grade CPUs with many cores that can host complex software modules through virtualization and appropriate hypervision, right? Some of them, some of these functions will be sold with the vehicles. Some others will be added when the vehicles are already on the market. It's so exciting that we are doing our part to build all of this. And by the way, this is the reason we wanted to start the series with a guest that represent very well all these trends, right, Dean?
That pretty much sums up the transformation we're seeing today. So without further ado, let's introduce our guests.
So, hello. Our first guest is Tarun Shom from BlackBerry. Hi, Tarun. How are you doing today? Can you tell a little
Yeah, I'm
bit
good, thanks.
about yourself?
Yeah, I'm a product management director working at BlackBerry in our advanced technology development labs. I'm calling in from the UK. I'm about 35 miles west of London, or 56 kilometers if you prefer. And I'm a huge tech geek. So I'm always keen to see what cool technology and features are being rolled out in the latest vehicles. And this makes IVY, which we're going to talk about today, a really interesting project for me to work on.
Thank you very much. And our next guest is from AWS, our colleague Michael. Hey, Michael. Can you please introduce yourself to our friends watching? What do you do in AWS?
Absolutely, Stefano. So I've been working at AWS for more than 8 years now. And in the past couple of years, I specialized in IoT technologies, spanning consumer devices all the way to production lines in the manufacturing space. And so there's nothing more challenging to me in terms of devices to connect than a vehicle that I can think of. So That's why I'm very excited to be here today as part of the IVY team to make it happen, and very excited to be part of this partnership with Tarun and BlackBerry.
Well, thanks so much for joining us today, guys. Why don't we go ahead and get started? We'll dive into the topics. So let's get under the hood. So, Tarun, as you know, we're in the middle of a transformation in vehicle architectures, just like we were discussing a few minutes ago. Can you talk to us about the consolidation of functions into domain controllers and even into high-performance compute, where we might find some virtualization as well?
Yes, that's correct. We're seeing a reduction in distributed ECUs on vehicles and a more centralized architecture being driven by the introduction of domain controllers, like you can see on the screen here. And we're also seeing further centralization into zonal architectures. Now, this migration path is what's moving vehicles towards a reduction in ECUs with reduced cabling and therefore reduced weight and connectivity complexity. We're also seeing compute capabilities in vehicles increasing, with DSP and GPU acceleration now much more commonplace than several years ago. And in addition to that, high-performance compute platforms are being introduced. So all of these advances can be leveraged for more complex compute functions within the vehicle, and they really open up many opportunities, like the one we're going to talk about today.
That's really, really interesting and a huge transformation for vehicles for sure. Michael, how does that impact the development of software in future vehicles?
Well, instead of sending systematically massive amounts of data in the cloud for processing, now we could perform more processing of the data at the edge. And that's any kind of processing, including machine learning inferences. But it's also about agility. The software deployments in the vehicle will become much more frequent. And also democratizing access to vehicle data for developers will fuel the multiplication of more integrated and context-aware applications.
So why are we not seeing this already? I mean, we've been doing this on smartphones for years, but what makes automotive so different?
Yeah, that's a really good question. It's one I expect many people ask because, vehicle technology does appear to be some way behind in terms of applications and services. And in fact, IVY came about as a result of this very problem because modern vehicles, they produce a wealth of data, but it can be challenging to capture value from all this data. We see fragmented architecture, multiple operating systems, bespoke solutions, but also there's a variety of proprietary data generators, and it's really kind of made acquisition of data difficult. What we really need to do is to be able to capture that data in a consistent way. And also, we want to make it much simpler to obtain insights into that data. And IVY does this, and it does it through normalization of data, but also by providing SDKs that allow software developers to quickly and easily build out insights on the vehicle. Now, also, IVY is OS agnostic, so it can be run across a variety of platforms.
That's really interesting and very powerful. So where would you deploy IVY in the vehicle, IVY in the vehicle? So it's at the edge, right? The vehicle for us is the edge. Where are we going to deploy it?
Well, with IVY, we can be really flexible on deployment. So we'd be looking to deploy IVY onto ECUs that have computational capacity to perform some form of edge inference or edge compute, since IVY is very much an edge-first solution. However, if there are some limitations, we can also work closely with automotive manufacturers to ensure that any data insights from IVY are tailored according to the compute budget that's available within the environment we're operating in. And as I mentioned before, we've built IVY to be OS agnostic, so it could run on QNX, it could run on Linux, or it could even run on one of those operating systems running within a safety-certified hypervisor.
So going back to the sensors, I have another question. Quite often when presenting connected mobility to customers, I talk about how ADAS and autonomous vehicles generate terabytes of data per hour from multiple sensors and technology in the vehicle. How are you addressing this challenge with IVY?
Oh, that's a great example of where IVY can be used to solve a problem. Since we're processing data within the vehicle, we can ensure that we only offload data that we actually need, if at all, really. And also, those insights that we're building on the vehicle, they don't have to necessarily consist of complex models. So we could also build a microservice within Ivy that could provide a service of pre-filtering that data and then outputting it at a desired sample rate. And that would really sort of reduce the bandwidth that's required to offload the data from the vehicle.
So now that we have all of this data coming from the vehicle, how do developers access it and make sense of it? Isn't this what Ivy is supposed to make easier? Can you give me a couple examples, Trent?
Yeah, sure. So if we were to consider two low-level sensors, to keep this relatively simple for now. So if we had an internal camera and a seat sensor, and we're capturing still frames from that camera, and also using the seat sensor to determine the weight that's occupying that seat. Now remember, of course, that Ivy will have normalized the data that's being fed up the stack from these sensors. Now as a developer, you can use those sensors as inputs to an insight that you're creating in Ivy. So in the example that I'm going to discuss here that you can see on the screen, the developer could use the seat sensor in conjunction with the camera frames to create an occupancy use case insight. Now, this microservice could then provide insights on who's in the vehicle, whether there's children, adults, pets, and where they're sitting. And then by combining the camera frames and seat data and using a trained ML model, we can determine that occupancy. And we could even then develop this microservice to provide further information on the occupants. So, for example, if the driver is distracted or passengers are being disruptive in an autonomous vehicle. And the developed software artifact that provides these occupancy insights is packaged as code that can then be deployed from the Ivy console, and it's updatable as well. And the insights produced in this example could be used in various applications. So, yeah, Michael, can you give a few examples?
Absolutely, Tarun. So Dean Stefano, imagine that now you have the knowledge of occupants in the vehicle, as Tarun just mentioned. You could create apps that could do things like restricting explicit lyrics if children are present in the vehicle. You could do things like alert the owner if a pet is left alone in the vehicle and temperature starts, to be dangerously high. What else? You could also perhaps have an application that would suggest you to take a break if you're showing signs of drowsiness as a driver. The beauty here is that all those applications, they can make use of the exact same insight. And the application developer doesn't really need to have any real knowledge of the embedded automotive development to take advantage of it. And I mentioned previously, this microservice, they're portable from one Ivy instance to the next. So what that means is that they can run on different vehicle platforms.
It's really amazing to see the impact that this can have on real people and real lives and the safety of the system. So I can definitely see that enabling a lot of partners between integrators, tier ones, OEMs. It seems a nice way to bring the ecosystem together. Do you see that coming?
Absolutely. You're right. Like the ecosystem of partners is very vast in the automotive industry, and we see Ivy being complementary to a lot of them, which is why we're already in contact with the tier ones, and we're building the first seed of that ecosystem. We really want Ivy to be an enabler for them by reducing the time it takes to integrate hardware and software in the vehicle. And as a result, that would be seen as an accelerator from the OEM's point of view. The idea is to drive consistency of the ecosystem by laying out interfaces. And we also envision Ivy to broaden the talent pool of that ecosystem by lowering the skill barrier that is needed by developers to get access to that vehicle data.
So, Michael, you just mentioned interfaces, and we all know that developers love SDKs that make their lives easier. Talk to me about what's available in Ivy in this perspective.
Right. So there's going to be different SDK accessible for different developer communities. Each one of those SDK will be tailored to that community specifically, so they can fulfill specific purpose as part of the ecosystem. So let me give you an example with two of those SDK. The first one is the vehicle SDK for developers who wish to create insights and get access to the vehicle data. And the other one is the Insights SDK for the application developers who wants to consume those insights.
Seems really interesting. Michael, what do you mean exactly by applications in this context?
I think that's a good point to clarify, actually, Stefano. I think Michael was using the broadest sense of the term application. It could be an application that's developed by an OEM, which sits on an ECU, which benefit from accessing insights produced by other vehicle systems. Or it could even be an in-vehicle infotainment application, such as an Android app, that would benefit really from being contextualized using the vehicle data.
So, guys, this is great. Let's go a little deeper, kind of take a look at some of the examples of these SDKs in action. So this is the time in our show where we actually roll up our sleeves in the shop, as you say, and we'll dive into some demos and some examples, even some best practices where applicable. So Stefano, why don't you pop the hood and get us started?
Okay, let's see the vehicle SDK first. It's like having an abstract representation of the vehicle, and for the developers to access the properties like speed in a sort of object-oriented fashion, right? So car.speed, just to have the speed of the vehicle. Is that right, Michael?
Yeah, that's a good way to put it. There's some normalization that happens in the lower layers of IVY to make that a reality. The advantage here is that developer can get access to that data through APIs. So it's pretty straightforward. And also this access to the data will be consistent across different vehicle platforms.
Could you show us what that would like with an example?
Sure thing. So we can take a simple example that might not be realistic, but that will illustrate the concept. So you might know that an engine can lose as much as 20% of the vehicle's horsepower depending on the elevation of the vehicle. So that happens if you drive a vehicle from sea level to the mountain. Therefore, most people that are doing off-road, they really like to get access to that information. So how would IVY help here in this context? First, we'll go through creating an insight as a microservice that will package that information. And then we'll display that information, let's say through an Android application sitting in the infotainment system to share it with the driver. So let's take a look at some code. It's not code that is coming directly from BlackBerry IVY, as the product is still under development, but it's just code that I've put together to, again, illustrate the concepts. So you can see here at the start in the init function, you can initialize a client for the location service as we want to get access to the location data in our example. You can imagine here, though, having access to any kind of vehicle data just by instantiating the appropriate service. So jumping below to the create insight function, you can see we use the location service client to get the current location of the vehicle. And it's only one line of code to retrieve that information. Once that is done, we actually create the insight with the latitude, the longitude, and you can see here you can add any other kind of attribute. In our case, we would call a mapping service to get the elevation for that GPS coordinate. And the last thing that is left to do is just packaging all of that information into the insight and publishing the insight with the last line of code.
So what's the role of the Insight SDK? I mean, can't you just use it to create a microservice that combines a handful of signals or perform some calculations, maybe a machine learning inference, or even just return a single value?
Absolutely. That's the whole point. So the Insight SDK, right, is going to be on the other side of the coin. Now we're catching the insight and getting access to all that information. And as you mentioned, it can be much more complex than the basic vehicle signals. So if we take a look at another example of code, this time from the application that will consume the insights. You can see here it's similar. We're going to instantiate the client at the beginning, and then every time that a new insight is produced, we're going to get it in the code. And you can see here, we can subscribe to it. And so there, once it's caught, you can do any kind of processing that you would like. And in our context, remember, we wanted to display that information to the driver. So that's why you can see the line of code here with update the UI. So Dean, I hope that clarifies how you can create insights and consume insights as a developer, and also show, how reusable those insights can be across the many applications that will live in a vehicle.
Yes, it does, Michael. And thanks for joining us with that, taking us through that in the shop segment. And most importantly, thanks to both you and Tarun for joining us today and spending time talking to us about IVY. We really look forward to having you on in the future, maybe with a nice referenceable implementation.
Yeah, thanks for having us on the show, guys. Look forward to seeing you again soon.
Yeah, thanks for having us. Talk to you soon.
Take care, guys. And let's wrap up now with a quick chat about what's around the corner.
What an awesome partnership we have with BlackBerry on the IVY program. I really can't wait to come back to you guys with a deep dive into our first customer deployment, right? So, but in the meantime, we have a few things to share. So if you're looking for more information on IVY, check out our blog as well as the recording of Michael and Tarun on the Automotive News webinar they did a couple of weeks ago. Great content and material to learn about IVY. And talking about what's coming next, Dean, you have something coming up in April, right?
That's right, Stefano. My good buddy, Nisarg Modi, and I will be speaking at World Congress Experience on April 13th and 15th. And the topic for my panel is Data and the Connected Vehicle, the Holy Grail or Panacea.
Whoa, what an interesting title. I'll bet on the Holy Grail. Do you want to give us a small preview of that?
Sure. The topic's quite broad, of course, but we'll talk about the role of data and how it helps us reach full autonomy. And what are the enablers of that? It isn't always about sending everything to the cloud, but how do we intelligently share data and events that take place in the car? And namely, from the performance of the ADAS functions. So maybe it's a low confidence path planning or perception event. And we want to send everything at that point in time, plus or minus a few seconds. But for the rest of the time, we'll just, sample the data at a lower level. So, if you think about it, it even gets into this vehicle software architecture. So I'll talk a little bit about what we've talked about today and the role and how I think that's really the accelerator for full autonomy.
Yeah, very interesting.
And then, of course, Nisarg, I forgot, mentions Nisarg's going to talk about EVs and the customer choice or forced by legislation. And of course, you think about that topic, there's all kinds of things going on from, government incentives to encourage you to purchase an EV and legislation that's been put in place to encourage the production and use of electric vehicles. So that's going to be a great topic as well.
And again, the electric vehicle rush, as I defined it before. So absolutely interesting talk as well. So we have a couple of other interesting events coming on related to NVIDIA. NVIDIA is one of the important players in this auto revolution. They power most of the vehicle artificial intelligence with their GPUs. And we have the GTC coming, right? So it's their annual event. So while our colleague, by the way, Sham, participated in a webinar at the beginning of the month, and you can find the link here in the show. We'll have Vijita coming in the GTC, talking about how the cloud can be used to accelerate the AV development. And I think that will be mid-April.
Yeah, there's some great content coming from some really talented AWS speakers. Really love you guys to tune into that. And not only that, our colleague Francesco will talk about what Renault is doing with high definition rendering of vehicle content on 4,000 GPUs. So he's going to kind of dive into that. And it's really, innovation powered by the cloud lots of data, artificial intelligence, and connectivity. These are all the topics that we're going to explore on our All Things Automotive series this year. I guess that wraps it up. One thing to take note, our moderator, Neil, will be passing on any questions that you have in the chat room. He'll respond to that and provide some links to some information that we mentioned earlier.
Yeah, but if you're catching this on demand, just send along comments or questions to Media Series live streams at amazon.com or use the hashtag AllThingsAutomotive.
And our show doesn't just end here with BlackBerry IVY. In 2 weeks, we'll be on with Jyoti Sharma from Verizon to talk about 5G and automotive and the mobile edge compute, the MEC, and everything that's happening at that network edge and the role that it plays from vehicle edge to the network edge to the cloud. So we're really excited to have her on and can't wait.
Yeah, and our colleague Savi from AWS will be there too to talk about wavelength, another technology that can significantly deploy managed service on the field and change things, right? So can't wait to hear that too. So that about wraps it up for our premiere episode of All Things Automotive. So, and see you in the next episode.